Our first exercise, exercise A03, is going to once again work on the same program. Okay, this time we are requested to add a second loop to the previous code. This is going to be a second loop which is serially arranged compared to the previous one. It's going to actually pick up right where the first one finishes. So we are going to have our first loop, end of the loop, and then our second loop start. And this loop is going to count down from the current value of counter. So this is something a little weird. We are using in both counting loops the same counting variable, counter. And this one is going to decrement the value of counter down to whatever its current value is, to 0. And both loops are going to, like I said, use the same variable. So it's not something that's going to happen very commonly. Okay, but I wanted to have at least one exercise illustrating this so that you have seen it in practice one time. You have seen two loops that use the same variable, and you understand that what happened in the program is that if I increment counter by 1 and count from 1 to 9, then I'm going to decrement from 9 to 0. And as a total result, as an end result, I will have 2 times 9, that is 18 iteration realized by my program. Okay, so once again, most loops that are one after the other are rather independent. Most counting loops that are serially arranged are independent. They use different variables. In this case, we want just to make something special that calls explicitly for having the same variable. I go up to a certain number, then I go down back to 0. Okay, so let's have a look at our code. This is our code, initialize to 1, etc., increment by 2. I'm going to revert back to incrementing by 1 only, so this is my dialog box here. Okay, and I'm going to put a second loop, which is going to decrement things progressively. So I'm going to use actually the same loop. I'm going to, oops, little error on my side here, I moved it. I'm going to copy it, go down, locate myself right after the first loop, and paste a copy of it. There you go. So I'm going to get rid of the hello word because I don't think that it brings a lot to this program. I'm just going to display the value of counter, and I'm going to say every time I display the value of counter which loop I am currently in. So I'm going to let the display as it is, but right before to start my loop, I'm going to add an output statement which is going to simply state we are in loop number 1, and this is what happened. So this is not requested of me, okay, in the exercise. Well, sometimes it's useful, to play around and add some things, some output statements, some display statement, etc., that help you understand what is going on in your code, okay? So even though that was not requested, I'm adding it in this live coding session so that you guys can see how I play with code to understand it, okay? And hopefully when you have like problem understanding some code, you will think also about adding some output statement here and there to just clarify what's happening exactly, so that you can look at the end result and understand what has been going on. So I've been doing a cut and paste while I was speaking, and I have now a display for loop 2 as well. Inside of loop 1 I display just the value of counter. Inside of loop 2 I'm going to change also my output statement so that I display only the value of counter, makes the output a little cleaner, if you will. And now I'm going to modify loop 2 so that it counts backward. As you see, for the loop number 2, I don't have an initialization of counter. Why? Because I'm using the value of counter right as it is once I get out of loop 1. So the only thing I know really about loop 1 is that I get out of loop 1 when counter is greater than 9. If I keep incrementing counter by 1, I can reasonably assume that counter will be 10. So I'm going to enter loop 2 with counter equal 10, and I'm going to display it and start decrementing. Okay? If I was incrementing counter by more than 1 in loop 1, then I would exit loop 1 maybe with counter equal to 11 or something like that, like was the case in our last run, and then I would have to decrement from 11 down to 0. So this first execution here is going to be relatively easy. I display counter, I'm going to edit my incrementation phase, and you are going to see for the first time that the incrementation phase can actually be a decrementation phase. Every iteration, since I know my counter will be greater than 9, I'm going to decrement it by 1, and then I'm going to test if I need to stop that loop or not. What is my condition to stop the loop? Well, when counter reaches 0 is when I need to stop. Okay, so my condition has been changed as well in the loop number 2. Well, let me give a try to this. Okay, my execution speed is maximal, so you are not going to see many things when the execution goes on, but we are just going to look at the end result and compare it to what we expect. So let me click to execute. There we go. It's doing its work in the background, and then execution finished. So let's take a look at what happened here. Loop number 1, counter is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. This part of my code is still working, which is always important to assess every time you modify code. You write code that counts from 1 to 9, you add something to the code, you must make sure that it still counts from 1 to 9. Okay? Then what happens? Loop number 2, we start at 10. Counter was equal to 10 to allow me to exit my loop, my first loop. Okay? So counter is 10, I display it, and I start counting down. Decrement it, next iteration counter is 9, then 8, 7, 6, 5, 4, 3, 2, 1, and when I reach 0, I'm out. The only thing that bothers me here is if I count up to 9, and then I count down, I would like total to be executing all of this display code 18 times. Okay? I count 1 to 9, then I count 9 down to 1. This is not what's happening here, because when I exit the first loop, the counter variable is not equal to 9. When I reach here for the first time, counter is equal to 10. It had to be greater than 9 strict to allow me to exit the first loop. So what can I do? Well, I could right here decide to decrement counter by 1. Or I could simply, in my loop, advance this decrement instruction up here. Let me scroll down to show you the result of this move. In my second loop, I start by decrementing, then I display the value, then I test. Okay, let's try this solution. Let me go back to the console, erase the display that was produced so far, and I'm going to execute this code again. Okay, what happened? I count from 1 to 9. This part is still good. Then I start counting at 9. I display 9, okay, and I count down to 0. And once again, there's a glitch here. Well, I'm not doing 9 to 1 and then exit the loop. No, I'm doing 9 to 0. And then I realize only after I display that I reached 0 and I exit the loop. So let's go back to the code. Let's clear this and go back to the code. What's happening here? My second loop, I decrement counter, then I display. And then I wonder if I should stop. Well, this is a problem because if counter is decremented here down to 0, I will display the 0 and then wonder only if I should stop. So I'm going to move this display statement to the second part after the condition. And this is my end result. Let me once again make sure that my master console is clear. It is. And I'm going to execute this code again. Okay, here is the result of this execution. I'm counting from 1 to 9, and then I'm counting down from 9 to 1. So we have been playing a lot with this code, okay, checking it, modifying it, etc. The idea is that those live coding sessions are not there just to provide you with a solution. They are there to provide you with an idea of how you can come with the solution. Pretty much what we want you to understand is the programming thought process. So the best way to do that is not to give you solution written on paper that you can then memorize. The best way to do that is to show you how we can come to those solutions, okay, step by step, like for a video, for example. However, this is also something that needs to be complemented by showing you alternative possibility, showing you how the solution that we obtain in one of those exercises can then be played with and modified to illustrate some concept of the course. So this is exactly what we have been doing here, and this is exactly what we'll keep on doing with many of the live coding exercises we will have in this course.